Okay, we might make a start. So can you hear me okay, Sanjin? Is everything okay? Am I coming through okay?
Excuse me?
Are you coming? Am I coming through okay? Can you hear me?
Yeah, I can look at your screen and I can hear your voice.
Okay, cool. Yep, that's good. So I'm showing my, just for fun, I thought we'd continue on with a lecture example. We're working on the benchmarking for string and StringBuilder. And so we'll give that a run. And there's my CPUs now, so not doing much. Okay. I'm running Zoom and a few other things, so they're not down to zero, but they're not doing much. But, so when we run this tool, you'll see that we're only writing single-threaded Java. I've only got one thread running, but it's going up pretty high. You can tell which CPU is running the running this bit, so it brings up pretty high. Just thought I'd show you that anyway, just so you can see. So we could improve our string performance slightly by having multiple threads, because we know what we're concatenating onto. We know it's just Java concatenating onto Java. We could improve things slightly by making our program multi-threaded, but even that's got limitations. And, even just for a silly example, when we're concatenating Java onto Java, it's still got limitations. We've got 12 logical CPUs, six actual CPUs, 6 physical CPUs, and yeah, you run out of steam very quickly. So even with multi-threaded programming, this wouldn't help string very much. StringBuilder and StringBuffer are still so much better. Okay, just thought I'd show you that so you can. I thought it was interesting. That's all. So we might do some short answer questions. What's a string in Java? What's a string? It's very hard when it's just me and one person in a class. But so strings are just a group of characters, or really it's 0, 0, 1, or many characters. Okay. It's an object in Java. It's a reference variable or field, or whatever you want to say, field in Java. And if it is not initialized to something, has the value null memory address. So we can actually say quite a lot of things about string. Okay, so it's 0, 1, or many characters. It's an object. It's a type of object in Java. It's a reference field or variable. And if it's not initialized to something, then it's got the value of null, the null memory address. So it's not the null string, it's a null memory address. And that's what Java does for safety. It initializes reference fields to null. And that's a protected memory address. So you cannot look at it, really. You cannot call methods for it. You cannot change it. And you're only limited to what you can do to look at it. You can really just not do much at all. Convert it to a string and get the word null out on the screen. That's all you can really do. You can't do much at all. These are pretty basic questions. We've got 4 people now, 3 others than me. Welcome aboard, everyone. And so what's the use of a string, and give an example? What's the use of a string? Give an example. You can do it in chat window if you want to. If anyone wants to join in. Okay. So strings to store 1 or more characters, 0, 1 or many characters. Give an example. There we go. There's an example. These are pretty basic questions. We've done far beyond these, but List a string method where you can compare two strings. Okay, can anyone help here? Storing names. Thanks, Byron. Yeah, Byron said storing names. Thanks, Byron. Storing names, yep. Storing suburbs, country names, addresses, emails, etc. A whole lot of uses. So who can list a string method that can compare two strings? We've done two, and we've done two versions of each. Two versions of each, anyone? Compare two, thank you. Thank you, Andrew. So compare two. And we've also got equals. We've done those two methods. That's the only way you compare strings in Java. And there's two versions of those. Compare two. And there's two versions of each. You've got the basic one and you've got the ignore case version. Okay. So that's the way to compare strings directly. You can also use starts with. There's also another method called contains. So there are methods to compare parts of strings, but to compare actual whole strings is only really those methods to compare all strings, entire contents of a string. This ends with, so on. Okay, so there's methods there to compare strings. For each of the given program segments, read the code and write the output. Do not execute these on a computer. In other words, try and work it out in your head before you run the code. But of course, you can run them in your computer later once you want to check your results. But so see if you can work out what's going to appear on the screen for this code. Assume the quotes are right. Copied out of a PDF. Okay, so we're comparing two strings. We're comparing uppercase J Java with lowercase j Java. Okay, so what we'll compare to return is uppercase Java less than lowercase Java, or equal to, or greater than. And of course, you need to think about the character set which you're using to compare the data. And we're using ASCII on most computers. On this computer, I'm using ASCII. So you could go up and you could view the clip library and look up J. And there's J, ASCII value of 74. And then go down to lowercase j, which is down here at the 106. So really we're comparing the start of the string is going to be 74 versus 106. And of course, 74 is less than 106. So this is going to return a value that indicates first string is less than second string. Okay, which means it's going to return a value less than 0. Okay, so less than 0. So we should see this else firing off down here. First string is less than second string. Okay. So if you're not sure, just go into TextPad and go to your little clip library, and there's most of the characters in the ASCII set. Okay, we're still missing the first 32, unfortunately, but they're the special characters anyway. Carriage return, line feed, all that sort of stuff. Page break. Okay, so that's that one. So what will be output? We'd see uppercase Java is less than Java. See on the screen. I'll compare result first. That's what we see on the screen. Any questions on that one? Anyone not sure why that's the answer? We've got 5 people now. That's good, 5 people. Pretty basic stuff. I think you've done this sort of thing many times already. Pretty basic stuff. Sentences.java. What's the output of the following code? Okay, so an article array, a noun array, a verb array, a preposition array. I'm going to try and make random sentences, I guess. Maybe, or maybe not. Okay, so j equals 0. Keep looping while j is less than 2. Add 1 to j after each iteration. So we're setting article to j, noun to j, verb to j, preposition to j, article 2 to j, noun 2 to j plus 2. So we've got some integers there. And we're using those to look up the arrays. So article, looking up the value for integer 1, article 1, sorry, noun and noun 1, so on. And we're appending them to a buffer. So we're using StringBuilder, there it is, StringBuilder buffer. So we're using a StringBuilder object to make it more efficient than string. Buffer.append. So we're appending the article 1, that index, which has got a value of 0. So article 0. So what's article 0 in the array? Anybody? The first item in the article array. Okay, the. Yeah, thanks, Byron. So Byron said the. So I'll put it here as a comment so we can work. The. Noun 1's got a value of 0. So the first noun from the noun array, the boy. Verb 1's got a value of 0. So the first one is drove. So it's the followed by space. So if you want to be right on the money, and then boy, and then space drove would be the first verb. Okay, and then preposition 1's got a value of j, which is 0. So then with a space 2 space. Yep. Well, nice, Brian. So Brian's got it worked out there. The boy drove to the town. And then noun 2's got a value of j plus 2, which is 2. Noun 2 is town. And then a full stop. Don't forget your full stop there. There's a little sneaky full stop at the end. And then a new line. Okay, so that's what would be output so far, is that there followed by a new line. Okay, so let's put that one down the bottom there. That's our first bit of output. And then we're going through buffer set char at 0 to character to uppercase buffer char at 0. So what's this doing here? So we're getting the first character, we're doing it to uppercase, and we're doing a set char. So what's that going to do? How's that going to change this? Okay, we've got 6 people now, 6. Another person's joined, thank you. That's good. So buffer, perfect. Yep, so Byron's got it there. So it's just going to put an uppercase first letter. Okay. So buffer char at 0 is going to give us the first character in the buffer, which is the lowercase t, was lowercase. And then we're converting that to uppercase. And then we're setting the first character in the buffer. Okay, the first character is at location 0, setting it to that uppercase version. So that's changing lowercase t to uppercase t. Okay. Let's flip through again. So now j is 1. So these are all 1. That's 1, and this is 3. Okay, so someone other than Byron, see if you can tell me what article 1 would be. Article for index 1. Anybody? Okay, so we're looking up the article array for index 1, which is that's 0, that's 1, so it's going to be a space. Make sure you remember the spaces. Noun for index 1 would be 0, 1, so it's just girl with no space around it. Verb for 1 would be jumped, space jumped. And preposition for index 1 would be 0, 1. So it's going to be the space from space. And then article 2, this article 2 is still value 1. So article 1 is A. And then noun 2. And noun 2's got a value of j plus 1, which is 3. So the noun at index location 3, which is 0, 0, 1, 2, 3. Yep, the girl jumped from a car. Followed by a space, followed by a full stop, followed by a full stop on new line. So that would be our output. And you've got to be careful with this part. So buffer set char at 0, buffer char at 0. So we're converting the first character to uppercase. What's the first character of the buffer? Okay, it's still a T. So we're converting the uppercase T to uppercase T. So it would still be lowercase a on the A. Okay, so well done, Byron. You're almost there. It's just this is a tricky bit where it's not converting the first character of the string of that line. It's converting the first character of the buffer, which is that character there. Okay, and then now we come back and loop again. J's now 3, and or J's now 2, sorry, which is not less than 2. So we're going to exit the loop. Okay, so we should see the boy jump from a town. The boy drove to a town, and a girl jumped from a car with lowercase a. Bit of a disturbing story, girl jumping from a car, but anyway, just a question. Okay, so that's it. That's the answer. That would be the output for that question. What's the output of the following lines of code? Okay, that would be the output. So if we wanted to, we could modify it so that the exercise in 2A compares 2 strings input by the user, and whether the first is less than the second or greater than or whatever. So we're talking about this question here. Instead of hard coding the 2 strings, get the user input for the 2 strings. That could be an exercise for you. That's a very basic question. That's the sort of thing we're doing back in week 2, week 3. So that's very, very basic. If you want to do that one, that's fine. But I don't think we'll do that one in class for now, unless people want to. If you do, please speak up. We can if you like. Let's do it. So we're going to change this question here to get user input. Okay. Compare strings with user input. File, save as. Compare strings.java. First thing I want to do is strip off the 2 starting characters. I'll use one of my little tools for that. I've written this tool, just add stuff to it when it's useful. And this is one of the things I use it for all the time. Copy. Stripping the first 2 characters off is something I use it for all the time. Okay, so now we've got something we can run. And of course, it's going to pick up on these quotes. So what do we need to declare to get user input? I'll let someone work on that. And how do we get the input from the user? So there's some code I'd like somebody to fill in the gaps. And we need an import as well. So we need an import up here. So what's the import? So someone can tell me that information. That'd be great. Okay, so we're going to use scanner. So we'll net the old values there. Let's use scanner java dot something dot something. So need that filled in. We need to declare a scanner object. If someone can fill that in, that'd be great. Util.star, yeah, the util.star is fine if you want to do util.star. Yep. We want to declare a scanner object. Then we want to say to the user system.out.println, enter 2 strings or words. And we want to get them to the user, so it's our scanner object dot something. And we're going to store that in first string. In second string. Okay, so Byron's given me the scanner part there, scanner. But there's one thing missing, Byron. Can you remember what was missing? You got to do something inside brackets here. You got to tell it which input device to use. System.in, perfect, yeah. System.in. Yep, so we're saying use the default input device, which is a keyboard. Okay, so. And then we use that scanner object to get input. So it's scanner.something. So what do we say here? If we're getting next 2 words, we use next. Okay. That gives us the next word. If we're comparing 2 lines of text, we might say next line. And that would be everything on that line. And the user would have to enter a line of data, press enter, enter another line of data, press enter. Okay, so it just depends on what input you want. I'm going for next words here. Okay. And that should be all we need to do. We've declared our scanner object. We've got some user input. And now we can compare strings and do whatever. Control 1, Control 2. Enter 2 words, fish and puppy. And what do you reckon? Fish is less than puppy because it's uppercase F. Fish is less than puppy. What do you reckon about Frank and Frankie? Is Frank going to be less than Frankie? Or will it be equal to or greater than? Any guesses? So one string shorter than the other. Does that mean it's less than, or does it mean it's equal or greater than? Or how does Java compare work? Okay. And Frankie is greater than Frank. So when the strings match up to a certain point and one's got more characters, then that's the greatest string. Okay. Right, that'll do us for that question. Any questions on that one? Like I said, pretty basic stuff. It's the sort of thing we're doing back in week 2, week 3. So that one there should be able to eat for breakfast without even thinking of it, really. Okay. Modify the 2b so that it generates and displays 10 random sentences. So we're going to use random numbers instead of that. We can do that as well if you want, 10 random sentences. want to change mine to be named 10 random sentences. File, save as. Ten random sentences. So we want to generate 10 random sentences, and we want to use random numbers instead of, which I think that's what it's saying. So we want to use a random number generator, and we've used two so far. We've used math.random, which generates horrible random numbers. If ever you're writing a casino application or some sort of gambling application or card playing application, don't use maths.random. You'll be bankrupt in no time. Okay, there's a much better one in Java called secure random. Generates much, much better, infinitely better random numbers. Okay, so we'll use secure random. It's slightly harder, I guess, but not really. There's virtually not much in it. So it's import Java dot. Let's have a look at our Java help so we can find out where to import that from. Secure random, and it's in the java.security.secureRandom class. Okay. And what methods are available? Let's scroll down. So you can generate seeds if you want to generate the seed, otherwise it's generated automatically. And it's probably going to use the system date and time and stuff like that to generate the seed. Some sort of random stuff that's in the system that's available. You can apply different algorithms, so there's different algorithms you can use. Generally, you don't have to worry about all that sort of stuff. You can get the seed if you want to see what the seed was. And basically, the next thing we're going to use is the next method. So we declare an object, secure random equals new secure random. Okay, so that's going to be the object we're going to use to get random numbers now in our program. And it's just a matter of saying dot next int. Okay. Now for article 1, we want a random number that's in the array size, so between 0 and 1, 2, 3. So we want a random number between 0 to 3. Okay, and what we can do to get that is we can use the length of the array. It's a property, it's not a method, don't put brackets there. Okay, it's not a method, it's a property. So article.length gives us the length of the array, which is 1, 2, 3, 4 items. We've got 4 items in the array, so that's the length of 4. So next int will give us a value from 0 to 3, which is just what we want. Okay. Leave the raggy code. Okay, so we're going to do that same sort of thing for each one, depending on the array. Just get a random number. So noun, we'll be using the noun array. And noun down here, we're using noun array. And verb will be using the verb array. Just make sure you're using the right array. Verb and verb array. Preposition will be using the preposition array. Article using the article array noun. So I've got all those right. Just double check. Article, noun, verb, preposition, article, noun, Because you don't want to get one that's got a long array and exceed your array size when you're trying to look up a shorter array. Okay, you want to make sure you get the index to the right array correct. Don't need the double. Don't know how they came in, but anyway. Righto. So there's our random indexes, and we're looking up random sentences there. Again, I was assuming buffer was initialized before the loop, but it's not. It's initialized inside the loop. So change again, sorry, change it again. And Byron was right. Okay, because we're recreating the buffer each time. Okay, I assumed it was created before the loop. So again, you've got to be very careful with your assumptions. Don't just think you know what code's saying. Actually, read what it's saying. So that is the correct output. Change my answer again. Okay. So each time through the loop, we're generating a new sentence, a new buffer. Okay, so it is the first letter of the buffer being capitalized. Phew. Okay, we got there in the end. Back to our 10 random sentences. So we've got max sentences there, 10. That's now capitalizing each sentence properly, and we're converting it to a string and outputting it. And so append's just appending it onto a brand new buffer. So that's fine. That should be all we need to do. And of course, that's no good. That's fingernails on a chalkboard to me. Yes, I've got issues. Control 1, Control 2. And there's our 10 random sentences. A boy walked from some car. Any car ran under any town. So you're getting gibberish out, but so I don't know if we've got any Bowie fans here, any David Bowie fans, but he actually used to write some of his songs using, he's cut out words that he liked and put them on the ground and pull them out of a hat at random. And that's how he made some of his songs. And they turn out to be fantastic songs. So even random numbers can, in the right hands with the right skilled person, can generate some great stuff. Okay, so any questions on that one? So we did get there in the end. And so it is recreating the buffer each time. You've got to be very careful of that. If that was outside of the loop, which is where I thought it was declared with the array, so I didn't pay attention. And so that would have just been initializing the first sentence. And we would have had that twice on the screen. So keep note of where that's initialized and created. Any questions on the 10 random? So why are we getting the blank lines between them? Okay, so why is there blank lines there? Okay, it's because we've got a slash n here. That means a new line, and we're doing a print line, which means I'll put a blank line after whatever you print is printed. Okay, so we've got that new line, and also that new line, or that new line after the print line. Okay, so again, our answer over here would be, yeah, that's right, Byron. So Byron's got it. There's 2 slash n's being used effectively. That's right. Yep. So that would be the correct output. If you want to make it really clear, if this is an exam question and you wanted to make it really clear that there was a new line there, you'd have to put a blank line there and a blank line there. And I would suggest, if this is an exam booklet, I know there's no exam this term, but just showing you what you could do. Rule lines here and say, this is all the output, or draw a bracket around it. Draw a curly bracket out here so that there's 4 lines in the output. Okay, make it really clear. If you showed it like this, and the question was worth 2 marks, you'd probably lose half a mark. You might even lose a mark. Okay, so that's the correct answer. It's print line, and there's a new line there. So be very careful of that. Okay, that's our 10 randoms. Any questions? Everyone okay? Let's go back. Write an application that reads a line of text and prints a table indicating the number of occurrence of each letter in the alphabet. Okay, so we're going to do an occurrence table or a count table. Okay, that sounds like a bit of fun, I guess. It sounds like fun to me. So let's do that, and we'll call it, it's a line of text and prints a table indicating the number of occurrences of each letter. Okay, so file new. So what we want to end up with is something like this. So if you enter box jumped 5 feet, then you want to see somewhere in there that there was an F that occurred 3 times, I think, and uppercase T occurred just once, and you probably want to do them in alphabetical order, sorted order, I don't know. Okay, just trying to work out what the question might mean. Okay, and do you want to print the occurrence of letters that aren't there? Like there's no A, so do you want to say A is 0? Okay, so these are things you've got to think about when you're doing this. The occurrences of each letter in the alphabet in the text. Each letter of the alphabet in the text. So I think we do need to say the ones that aren't there as well. Each letter of the alphabet. So B was 0, C was 0, and so on. D was 1. Do we want to distinguish between uppercase and lowercase? Just so we don't get so much data flowing up the screen, let's, for our example, let's make so we're going to treat uppercase and lowercase the same. So T and lowercase t is fine. So T would be 1, 2. Okay, so who's got some ideas on that one? Any ideas? So we want to have an array to count all the letters. So we want to have public. I'll call it char counter. I'll give you some gaps to fill in, see if you can fill in the gaps. So you want to declare an array, contain the counts, reads a line of text and prints a table. So we're going to get a line of text from user, so we need a scanner. Scanner. Get scanner input. So we want to do that sort of stuff. Then we want to loop through all characters and count them. And then we want to display the counts to the user. That's the sort of thing I think we need to do. If anyone thinks otherwise, please tell me. Okay, but I think that's right. Declare an array of counts and make sure they're all 0. And we've got Java, so Java does that automatically for us if we declare an array of ints. Get user input, the scanner, loop through all characters and count them, and then display the counts to the user. Who can do any part of that? We've got 6 people, we've got 5 people and me. Who can do part of that? Can anyone declare an array, a suitable array? Want someone else to declare the scanner? If someone can help me with part of the loop, that would be great. And if someone can help display the results to the user, that would be great as well. So that would be a loop as well. Okay, so we need 2 loops. Display all the characters that are in the array and their counts of each letter of the alphabet in the text. just as alphabetic characters. We're going to ignore numbers, spaces, tabs, full stops, etc. Okay, so we're going to ignore a whole lot of stuff. Ignore those, and then display the counts to the user. Okay, let's declare an array. Int counts array equals new int. We could make it 26. There's 26 letters in the alphabet. That would be okay. Again, we want to make that a constant. I don't like seeing 26s everywhere, so we'd make that a constant. So let's do that. We could make it a constant here, or just make it a class constant. We don't have any other methods at the moment, but I like making them class constants so they can be used by other methods if we need them later. Public static final int max chars equals 26. Okay, get user input. Anybody got some code for me to get some user input? Byron typed what we need just earlier, so I'll grab that and type it for the prior question. System in, it looks good to me. It says read a line of text from the user. System.out.println. Dyslexic today. Enter a line of text. And then we store that in a string. Scanner dot, what do we say there to get a next line of text? We want a loop for int c is equal to 0. C is less than what? C++. Okay. Next line, perfect. Thanks, Byron. Next line. Okay. Here's where the tricky bit's going to be. We want to check if it's a character. Okay. We want to ignore spaces, numbers, tabs, full stops, etc. So is there a function we can use to tell us if something is a character? Okay. And let's look at the character array. Or character class, sorry, character class. And scroll down. There's a bunch of constants. Let's get down to the methods. Go down to the is methods because that's going to tell us something. Is alphabetic. Determines if the character Unicode point is an alphabet. Is in an alphabet. So that looks pretty good to me. Is alphabetic. Is BMP code point. Is defined. Is digit. That could be used to pulling out the digits if we need to do that. Oh, g'day, Wayne. How you going? we desperately need you here. We're just we're doing a question where we're getting user input from the user and we're counting the number of occurrences of each character that they type in. So if they type in the fox jumped 5 feet, we'd see there were 3 Fs and 2 Ts. So we're counting uppercase and lowercase is the same. Okay. No A's, no B's, no C's in this example. And 1 D and so on. So that's the sort of thing we want to output.
Sounds like fun.
That's fun. Yeah, it sounds like fun to me. We're not getting much feedback though, so maybe it's not fun for everybody else. But anyway, let's proceed. So looking at the character class, looks like the method we need is alphabetic, but there's other ones as well. There's digit. There's is Java identify letter. Is letter. Oh, that might be a good one too. Is letter. Is letter or digit. Is lowercase. Is and so on. Is mirrored. So I'm starting to look at that is letter one. Let's look at that one, see what that tells us. A character is considered a letter if it's one of the following: uppercase, lowercase, title case letter, modified letter, other letter. Not all letters have case. Okay, that sounds good to me. I think we'll try the is letter and see how that works. And if that doesn't work, we might have a look at is alphabetic letter. Okay, so we want to go through here and if. So we want to get the length of the input. That's going to be the length of the input there. So if they type in 50 characters, we're going to go through 50 times in the loop. Gee. Length. And it's not a property, it's a method, length property. Sorry, length method. That should be a semicolon. So int c equals 0, c is less than input string.length, semicolon, c++, going through the characters in the string. If that character, so we're going to use the char at, good old char at, if that character is a letter, if that's true, then we want to count it. Okay. And we want to get the lowercase version or uppercase. We'll do the uppercase version. Don't forget uppercase is uppercase U, uppercase C. Char. That's a pirate character. Char. There we go. So uppercase char, we're getting the character at the current location, converting it to uppercase. Now we're going to try and use that to index our array. Okay. So our array's got 26 alphabetic characters in it. Okay. How can we convert this to be an index of our array? Okay. Now you might remember from an earlier week, chars are really just integers behind the scenes. So if we printed uppercase, if we said int val equals uppercase char, we would see the value of whatever the character was on the screen, the ASCII value. So it's that value from that table we just looked at. Document selector. Whoops, not document selector. View clip library. Okay, so uppercase A has got a value of 65. Okay, so to convert this to an index, we could say equals uppercase char minus 65, but that's pretty horrible because what's 65? Okay, it's a magic number. So we could make it a constant and explain it up here. That would be a good thing to do. Or we could do this, uppercase A. Okay, so we're converting whatever the character is to an index of the array by subtracting uppercase A from it. So if they type in, if C was that character we're using, which is 67, index would be 67 minus 65, which is a 2, which is correct because 0, 1, 2. 0 would be the first letter in our array, which is A, 1, 2. So that would give us the correct answer. Okay, so now we've got an index for our array. Now we just have to go update the counts array. And how can we update the count of that location in the array? So we want to get the current count and add 1 to it. Okay, so that's our index. How can we update that count at that location? Plus equals, yep. That's one. Thanks, Wayne. That's a good way to do it. Would this also work? Would that work?
I assume so.
I assume so as well, but it looks really scary. So I'd much rather do it that way. That looks really scary to me. I would stay away from that sort of code. And plus equals 1. I'm sure that's going to work. Okay, get the current value, add 1 to it. Okay, so that's the hard part. We've done the is letter. That was really the hard part, and converting it to an index. Again, that's a magic number. So I would say public static final int first. We'll make it a char even. First letter equals A. And then say that's the first uppercase alphabet. Just make it really clear that's what you mean. And I'd use that down here. Try and avoid any magic numbers in your code. 65, 26, 100, whatever they might be, try and avoid them. Make them constants to slap a nice big comment on them. Or in that case, a little comment. Okay, so we've got the count. That should give us the counts. Let's display them. That's the easy part, displaying them. So we don't loop through the number of letters now in the input. We're going to loop through the size of our array, which is counts array. And system.out.println. Counts array, square brackets, C. That's going to tell us what the count is. So we're going to see counts for A's, counts for B's, but we're not going to know what letter it is. Okay, so it's not very helpful. We're going to see a range of numbers go up the screen with count equals in front. We're not going to have a clue what they mean. I mean, we'll know because we've written the code that the first one's for the counts for A, uppercase A, but the user's not going to know. So what can we do? Can we convert this back to a char that we can use? Char out or count char C plus something. Can we do something there to convert it back to a back to one of these guys? So we want to try and end up with
the first letter again.
First letter, that's right. Add first letter on. Okay, so we'll see. Instead of outputting that, we might say count char, which we've created, and output the counts array. Count for that one. That looks like it should work to me. I can't see any issues there at the moment, but then my eyes haven't been the best today. Take out some blank lines. It looks pretty good. We're ignoring numbers, spaces, tabs, and full stops, providing they don't come out as an is letter. Okay, as long as this letter doesn't return true for a space, we should be fine. Okay, but if we'll find out pretty soon anyway, because our array size will be exploded, and we'll have a array index at a bounds error if this doesn't work the way we expect. Okay, that's looking pretty good. Let's enter that bit of text there. Control 1. Got an error. Got to do an import. Import java.util.scanner. Ooh, is letter. Cannot be. Oh, sorry. Sorry. With character class methods, they're all this. Yeah, with character. I was calling the string version. So you got to go character dot, and you got to pass in this in the character you want to check. Sorry, these have got to be static methods. So if character dot is letter, and then you pass in the character. Sorry, I was doing the string version, not the character version. Again, two uppercase is the same for characters. I was doing the string version. Pass in the character again. Okay, so the string versions work differently to the character versions. For character versions, it's all character dot. Counts array dot length. Length is a property, not a method. So I'm going to make it a property. I just copy the code from here. That's why. Counts array dot length. Incompatible possible lossy conversions from int to char. Okay, so to keep Java happy, Java's thinking, I kind of know what you're meaning, and it's, but the way to keep Java happy is to go char at the front. So in other words, you're doing this addition, and you want the results to be converted to a char. Okay, so we'll do that addition first, and then we'll convert it to a char, and that'll keep Java happy. Okay, so this area here says incompatible types, possible lossy conversion from int to char, because we've got ints being added to chars. We could have, if we've got big numbers, we could be losing digits. So here we're just keeping Java happy that we're truncating it all to be a char length data size item. Okay, so we had a few things to fix there, a few tiny issues. Control 2, and I'll grab that text from up here to see if we get the. So we should have three Fs. we've got 3 Fs, we've got 2 Ts, 2 Ts. We should have one H, yeah, 1 H, 1 I looks right, 1 J looks right. Anyway, basically looks right. If we wanted to do 2 columns instead of that, we could do 2 columns to make it so our output's a bit smaller, or 3 columns. If you want to do 3 columns, we could do that. Why don't we do some 3-column data? Okay, so that was 1 column, just all the counts on the screen, and we could say if. So how can we do a new line every 3 columns? What's the tricky bit of code we could write to do that? C and 3, we need to put something inside here. There was a little operator we used. It was a really good operator for this sort of stuff. Print line. Percent. Thanks, Wayne. Yep, percent operator. Okay, so good old modulo. So if C is evenly divisible by 3, so if that's equal to 0, then we've got a evenly divisible by 3, and we do a new column or do a new line. Let's look at that. See, control 1, control 2. Out there, so we've got the 3 columns coming out. There's no gaps between them. Let's put some gaps in. There's other ways we could do it. We use string.format if we wanted to, but that's fine as well for now. And we don't want to have a gap on the first column. So if C is greater than 0 and it's evenly divisible by 3, new line. Okay, so we'll only do it when C is greater than 0. Save doing it on that first one where A is on its own. Okay, and we've got a little bit of mess there when we go to 2-digit counts. Okay, so again, we can fix it up by just using a little bit of a system out print line, or string.format, sorry, string.format. So we want to make this count so it's always 3 digits. Okay, but we want to have 3 digits, but if they're leading zeros, we want to just make them spaces. So %d is the right format character, but how do we make it 3 characters wide? It's something you need to do. Something you need to do in here. Anyone remember what it is? %3, %3d. Okay, that should do it. So it's 3 characters wide. So you can make it so it also puts it at leading zeros if you want to, by just making the format a bit different. That should be fine there. Let's get some text. That's looking much better, much neater. Okay, we could probably bring that down onto the next line here at the end, so print out a new line after the loop. And we've got D up here, so it's not right. D's up there when it's so we'll do a print line after the loop. And we want to take care of that case where D is so let's change that slightly. Any ideas there Anybody got any ideas for fixing that? So we've got the 3 columns there, but D's coming out as well. So when C, that's first character, so C0, C's 1, C's 2, C's 3. So that's the correct time to make a new column. But maybe we want to change that slightly. So it's C plus 1. Okay, so C plus 1% 3 is equal to 0. Maybe that's the right answer. Let's give it a try. No new lines here, so that's no good. Any other ideas? What can we do to fix that? So it's every 3 columns. Probably the easiest way. Look, probably the easiest way, rather than trying to work out what indexes things are and all that sort of stuff, just add another counter. Int count is equal to 0. Count plus plus. And if count is equal to 3, that's probably the easiest way. Okay. Then it's much clearer code as well. Okay, so well, if count starts at 0, it'll be every 3 columns. Okay, every 3 columns. That should be right now. And that's looking much better. So if you start getting into complex code when you're trying to use an index and trying to make it so it works, and there's a simpler way, just go for the simpler way. Create another counter, add 1 to it every time you output a character. If it's equal to 3, whatever, or 4, or whatever you want, every 4 columns, and then set it back to 0 again. That's a simpler solution than trying to work out how to fix that A, B, C, D stuff. Let's do the big test again. So we've got 4 columns coming out now, which is what we wanted. I changed it to 4. Every 4 columns. Any questions on that one? Anyone got any questions or issues, or want me to go through anything again? Everyone happy? So the tricky part was the working out whether it was a letter or not. Okay, thanks, Wayne. All good. Working out whether it was a letter and then converting that letter to an index of our array. That was probably the trickiest part of the question. Okay. And once we worked out that part, really the rest just fell into place. That was probably a little bit tricky as well, going back the other way. Okay. No questions? All good. The next question is write an application that reads a line of text and prints a table indicating the number of occurrences of each word in the text. It's the same sort of thing, but for words. Okay. Do you want to work on that, or do you want to skip that one, leave that one for you to do on your own? We can move on to other questions if you'd rather. So instead of keeping counts of each character, we're going to keep counts of each word. So it's a little bit trickier now because we can't use the word to look up an index. We have to go through and find where the word is in the array and add 1 to its count. Or if the word's not in the array, add it to the array and set its count to 1. So it's a bit of a trickier question. Oh, we might as well do it. Might as well do it. So that was our char counter. Okay, let's do a new one. File new. The application should include the words in the table in the same order in which they appear in the text. Okay, so not only are we keeping track of the words, we're keeping track of the counts of the words as well. Okay, so first thing I think about when I see that is that I think we really need a data class, and each item in the data class is a word with a number of with its count. Okay, and then we can just add that to an array list, and then we can sort by that word in the array list. Okay, so really I'm thinking about making an array list, not an array, because we don't know how many words we've got, and we need to keep each count in each word. So either we're using parallel arrays or something horrible like that, or we can create a data class and do it properly. So I reckon let's create a data class and do it properly. So word counter. counter, public class word counter. So like I said, we could do it with multiple arrays. We don't know how big the arrays are, so we could either set them to some crazy size. String words. Okay, so, something that hopefully we won't run out of. And if we're doing this in a shared environment on a server or something, this is going to waste a lot of memory. PC doesn't matter, but on the server it matters. So that's not good. We'd have to have words and their counts. Okay. And if we have to go through the word array for each word, so for example, right, let's go through and search the word array, see if that's in there. If it's not there, add it in and set its count to 1. So we're going to set its count over here to 1. And when we want to search that word, sort that word array at the end, because it's going to appear in sorted order. Hang on. The application should include the words in the table in the same order in which they appear in the text. Ah, okay. We'll also do it. We'll also do an extra. We're going to display it in sorted order. Okay, so as soon as you start having to do sorts, and this array is changing, and you've got to change that array exactly the same. So if you move the third word to the fifth word, you've got to move the third count and the fifth count, swap them around. You start getting into nasty stuff with this sort of parallel array stuff. So I wouldn't advise doing it parallel arrays. And we don't know how many words we've got. It says a line of text, but let's make it work for any number of words. Okay. So why don't we create a data class? And in here, because we know about object-oriented programming, and when we're done, we can do things properly. Let's create a word class. So each word's going to have a count. It's going to have a string, which is the word. Okay, so we want to have a constructor that takes in the word, and another one, public string get word. That's probably enough methods for us. Maybe we don't even need that one, but I'll add it in there just in case. Okay, so, and I'm doing all of this off the top of my head, so I'm just thinking as we go. So we've got a constructor that takes the word and sets a class value, that class item to the word, and sets count to 0. And this one here, get word, gets the word. Probably also want to get the count as well. Int get count. Maybe a mutator to increment the count. Something like that. So we've got two private data items. Default constructor, a parameterized constructor. We're not passing in the count because the count should be 0 when a word's first added. Get word gets us a word, count gets count. Inc count increments the count. There's more we could do, but that's probably enough for a basic class. Okay. And if we're doing this really properly, really properly, I'd create it. In fact, we've done it already with dogs and dog. We've already had an array class. So let's do that. Let's do it with dog with this as well. So we'll have a words class. So doing the same sort of design we had with the dog and the dogs class in week 8, where we had the data class in one array, in one class, the data class. Then we had the array class, and then we had a driver class that worked on top of it. Okay, so let's do the same thing. These could all be separate classes by the separate files. So if we made that public class, we could move it out into the word.java. If we made this public class, we could move it out into words.java. That's fine. So here's going to be our array list of word. So array list of that class. Okay, so this will be where really the guts of the processing happens in this class. Okay, so this will be the brains of the application in here. And so we want to. So you can create it up here as well as in the constructor, but then why do it in both places? Probably that's a better way to do it. Declare it up here and then initialize it in the constructor, which is the way things are normally done. But you can do it in both places or just up here if you want. It's really all the same because it's happening when it's created. And then we want public string or public void words string words string. And then we want to maybe public void display word. That's the sort of things I'm thinking of. Okay, so there's going to be a whole string of words coming in separated by commas. We'll assume they're comma separated. We'll ignore commas and full stops and all that sort of stuff. In fact, we might even strip them out. Okay, everything just froze up then. It's back again, I think. Everyone here? Okay. So it's still got 40 minutes to go, so we've got plenty of time to do this. And this really is doing it the proper way. So we could have done it this horrible way down here, and that would have been a nightmare. Would have mean our code wasn't reusable at all. What we're doing here is making it so all our classes are reusable. Okay, so okay, so that's the sort of processing we want to do. We're going to remove full stops, commas, and semicolons. We'll remove some basic stuff just for now. If this is a real application, we'll be removing all sorts of stuff. So how do we remove stuff from a string? There was a method we called in the lecture. Okay. How do we remove double spaces? How do we get an array of words in the word string? We did all these things in the lecture on Wednesday. Okay. And for int w equals 0, w is less than words array dot length. It's the property w plus plus. Anyone remember how to remove stuff from a string? Was it the remove word? Was it remove, or was it something else? It was a really simple command. You could just do that sort of thing, and with what you want to change it to. So was it remove, or was it something else? Any ideas? We could look at the string class if you like. String in the help. String, and you'll see down here there's a whole bunch of methods. The strings. You could see if it contained any of the stuff with index of. That can help you search for characters or strings, substrings, and so on. And but we just want to remove them all. So there's a replace all, and there's a replace old char with new char. Replace char sequence, replace string. There's replacement. So there's replace and there's replace all. Okay, and this takes a regex. Regex is a really something we don't even talk about. Regular expressions, they're very powerful, compact things. We don't really want to talk about them, but we can certainly use them here. We can certainly use that function here. Replace all. So replace all is what we want. Replace all. Replacing all full stops with nothing. Replacing all commas with nothing. Replacing all semicolons with nothing. And there's a whole lot more we could do, but that's enough for us. Okay. Remove double spaces, same sort of thing. Remove double spaces to single spaces. Replace all. Okay. Anyone remember what the command was to pull out all the words in a string, or pull out all the items in a string by commas or tabs? And we would do that in class. We did tab separated data and comma separated data. Split, perfect. Thanks, Byron. Well done. That's a great command. If you're keeping a summary of useful code, make sure it splits in there. It's just so brilliant. It can save you so much time when you need it. Okay, so that's pulling out all the data separated by spaces. Okay. So now we've got an array of words that are in our ArrayList. What we want to do now is string word equals words array W. So we're getting each word out of the array. We want to see if it is in our array list already. Okay, so we're going to loop here. And if it's not there, we want to either add it in or add one to its count or whatever. So what we need is a method to help us search through our array list, which would be a nice little thing to do as a separate method because it's going to be reusable if we extend this later. So let's add another method in there. Public int find. Okay, or search, if you want to say search. Okay, search is fine if you want to use search. Okay, so you want to loop through all words in our array list and see if we find a match to that word that was passed in. So, and if it's not found, we want to return -1. So int index equals -1. That means not found. Return index. So we're just filling in the body, the basics of the method now. Now we're going to fill in the body. So we want to loop through the array list and search for the word. If it is there, return its index. Okay, so a little loop through our array list. That's our array list. So we want to go for k is equal to 0. K is less than array list dot something. How do we get the length of an array list? Plus plus. Say if words array list dot. How do we get the item in the array list? That's getting us the words item, the word item, and then we want to use the get word method on that. So we want to get the item that's in the array list, that location, and then dot get word, and then we want to do a compare to. What the user passed in, what was passed in, and see if that's equal to 0. And then we found a match. Beautiful. Yep, that's size. I said length to try and throw people off, but yes, you're quite right. Wayne, well done. So size. And what do we do to get an item out of an array list? It's a special command we need. It's not set. Get. Perfect. Get. Okay. Okay. So that gets us a word record out of the array list. So that gives us a word item or word object. And then we can use get word to get the word that's associated with that item. So that's going to call this get word method here. Okay. So we can say index equals k. That's found a location. And now we want to exit the loop real quick. We don't want to keep looping. K is equal to, let's just make it equal to our exit variable, exit value. Okay, so found a match. And then we want to exit the loop. Okay. Do we want to make it so they're all uppercase or lowercase? Do we want to care about case? We can worry about that later. But you could make that compared to ignore case if you wanted to. So now we can use that method down here. Int index is equal to search for our word string. Just became unstable again, back again, I think. Okay. Okay, so if index is -1 is less than 0, then we want to do something else. We want to do something else. So to do something is add the word to our array list. Down here we want to increment the count of the word in our array list. So see if you can write the code for any one of those. Okay. So if index is less than 0, we want to add a new word to our array list. In fact, we want to add that word to our array list. So see if anyone can write that code. And then if the word is in our array list, we want to increment the count for that word. Okay, so think about those.
Your internet's not
Am I back? Is it okay?
behaving today.
Have we dropped out?
No, you're just pausing fairly frequently.
Yeah, the pause doesn't really matter as long as the sound doesn't drop out. If the sound drops out, that's bad.
It's just everything from your video and audio is shuttering. So,
okay. I wonder if I should do a quick I might do a quick reboot. So just a sec, I'll be back in a second. Actually, I don't know if I can do a reboot because I'm recording locally. I think I might mess the recording up. I'll give it a try anyway. Has it come good now? Is it still bad?
It's better now.
Better now? Okay. Yes, it's not my internet that's doing it. It's actually Zoom dropping out. So I think it's a load on the Zoom servers again. Okay, well, I think we'll try and proceed because if I do a reboot, we might drop out. So let's try and do this part. Add a word to our words list, to our array list. Okay, so our array list is words array list. I'm going to go .add, adding an item to our array list. And our array list contains word objects, so new word. And we're going to call a constructor here. And what's the word we want to pass through? And it's that one. Okay, so we're adding a new word to our array list. Okay, so we're creating a new word object and adding it to our array list. Okay, here we know the index, the words in our array list, so we just want to update the count. So it's words array list dot get index. And then we want to call something. So that gets us a word object in our array list. That gets us a word object. So we want to call this method for our word object. Increment count. And that should be it. Okay. So we're adding a word to our array list if it doesn't exist, and we're increasing the count by 1 if it does exist. Now there is one little issue here. I don't know if anyone spotted it. There's a little issue up there in that default constructor. Can anyone say what it might be? Okay, and it's when we're adding a word, we should set the count to 1. Okay, we've added the word as an object, so the count should be 1 by default, not 0. Otherwise, all our counts will be out by 1. Okay, so that's all, just a small thing. I think we're ready to do a test. Maybe we'll add the display words in as well. Let's do that. So we're going to live through all items in our array list. So it's that sort of loop. I want to display them to the screen. So pretty simple code. Just displaying the word and that's at that location in the array list, which gives us a word object. But why don't we do a toString on it? Add a toString method to our word data class. Okay, so add a toString method up here to our data class. Let's make it so we format our data nicely in columns. Format %s. So we'll get the word, and we'll make it so it's in a column of 25 characters. Each word's up to 25 characters long. We'll make it so it's left justified. So we put a minus in there. Plus string.format. %d count. We'll make it so each count is, say, 5 digits with spaces as leading zeros. That means all the counts will line up nice and neatly on the right-hand side. So I'll have left justified words and right justified counts coming out for it. So I've written a lot of code here, much more code than we should write without testing. But anyway, let's see how it goes. So let's come down and do some testing. Let's create a words object down in our main. Words equals new words. And we want to pass through. I'll get the add words there, that's all right. Words.add words. We're going to pass through a string here. And I'm going to grab the string for the question. So just bear with me, I'll go up here and grab this. Okay, so you've got the string for the question there. We're calling our add words method, which takes a string of text and it splits it up by, removes all the full stops and everything from it, removes double spaces, splits it up by space, get the words, and then adds the words into our array list or updates the counts for them if they exist. Then we should just better say words.display words. Which is calling our display words. Oh, display word count, sorry, display word counts. Okay, control 1. ArrayList, could do an import for ArrayLists. Import java.util. For k, for int k. Check there's no other ones like that. Yep, that's all part of that same error. That's all part of that same error. Yep. Another one, int k. Cool, okay. So we've got spaces of 1. Okay, so our program hasn't worked. Let's just see what's going on. This comes the fun part now. So we're adding words and we're passing through an array of words. Let's see what we end up with. Let's display this array list to the screen so we can see what we end up with. System. Out. Line. Words array k plus a space. Do that in a loop. I might just do print so not scrolling up the screen too much. So it's our words array dot length, our length property. So we're going to display all the words to the screen here that are in that array. So we're just checking the split did the right thing. And after that, we'll do a print line. Just see what we get. Print ln. Okay. Just doing some testing, see what we get. Making sure this does the right thing that we expected. Okay, so we're getting the space out, nothing else. So it looks like split's doing something we don't expect. Let's print out our word string before that, after all the replaces are done. So I'll put the array there as a label and the string as a label, just so we know what we're seeing. Okay. So word string is nothing, and word string's array is nothing. So what's going on? What's going on? Anybody got any ideas? Let's do a print of the word string right at the start. Okay, make sure we're getting the word string coming in. Control 1, Control 2, and there it is. So it's coming into the method. But by the time it does the replace alls, it's back to nothing, a blank string. These replace alls have destroyed it. Anybody got any ideas of what might have gone wrong? It's something you really got to watch for, especially in Java. Okay, let's go back to the Java help, and you'll see that took a regex.
With the regex.
It's a regex, exactly right, Wayne. Whenever you see regex, so if you see the word regex, make sure you're if a shiver doesn't run up your spine, then you're not doing it right. Okay, so be very frightened of regexes. They're very powerful. It's very powerful, compact. You can't really call it code, but you can call it formatting data, formatting commands. Yeah, they're like commands. They're very powerful. So basically, whenever you see a method that takes replace all with a regex, be very careful. Replace first took a regex. Contains. Let's still look at replace. Just replace on its own. And we want that one which takes us, which takes a char and replaces it with a new char. Okay, so replace doesn't take a regex. So let's try and use replace. So replace replaces all characters. So that's all right. Mosquito in your collar, that becomes fine. So let's try and replace those with replace. Okay, but it's char with char. So one just said a funny thing I put in here. It's well worth commenting on. That's right. And some people love regexes. We don't even talk about them in this course, but some people love regexes. Most people are very worried about them and don't like them. And I certainly am in that camp. I'm worried about them, and I try and avoid them when I can, because I have to go back into that regex space, which is a nasty little world of compact commands that I don't like. So let's try trying it with replace. But the thing with replace is we've got to use chars, and you can't replace a char with a nothing char. There's got to be something in there. So we're going to replace a char, and it's got to be single quotes now because it's chars. We're going to the replace, which takes chars. And you can't replace it with a nothing char like that. There's got to be something in there. So you've got to put a space in there or something in there. Okay, so let's get rid of those three. We've still got this one because we want to replace double space with single space. That's, we can't really avoid it unless we do it another way. We can do it another way, but we'll come on to that later if we need to. That's compiled okay. So I had to change all our double quotes to single quotes here when I went to replace. There's only a char version of replace. There's not a string version. So replace is a char version, and there's a char sequence version, which you can also do with strings if you like. You can do some tricky pressing. We won't get onto that. We'll just use a char version. I don't want to make it more complex than it already is. Okay, so char version. Let's see how that goes. We can do a quick test. Oh, and now we're getting something. So the words array was correct. The word string was correct after the replace. So that's all we need to think about. Okay, so one of those, either dot, comma, or semicolon in our regexes was killing everything. Let's not ask why. That's beyond the scope of this course. But so question has got one occurrence. Application has got two. Applications. There's two applications. There's three ofs. 1, 2, 3. There's three ofs. There's a whole bunch of ins. Ins got 5. 1, 2, 3, 4, 5. Yep, 5 for in. So it looks like it's doing the right thing. And they're coming out in word order, which is what the question wanted. Okay, so question's the first one, 6 and so on, right? All the way down to appear. So appear should be the last unique word in our string. Yeah, in the text is already in the array, so appear is the last item that's unique, so that's correct. Okay, so we've got the first word, we've got the last word, or the last unique word, and the multiples are coming in when they're getting counted. Okay, so we could now sort that array and do it so it's coming out in word order. And that's something we did with dogs. With the dog names, we had it sorted by dog name and the counts and the ages are all coming out. So dog and name are coming out in order of name. So you can have a look at our dogs class there if you want to do that. I don't really want to show you any more. There's some tricky SQL, not SQL, Java I could show you to do with collections. Very powerful topic. Powerful. And we could sort. We could sort our array by name or count by with one line of code, one line of Java code. They're very powerful, but they're outside the scope of this course. Okay, we do those in the follow-on course, and they're quite good fun. So keep an eye out for collections and iterators. They're really great little utility classes in Java, very powerful, and we could sort the array by name or count, or if there's other fields in there, if there was number of syllables or something like that, we could sort by that as well with just one line of code. Okay, but they're outside the scope. And I don't really want to show you when we've only got 10 minutes left. So I showed you exceptions in the lecture, which I shouldn't have, but I don't really want to show you these. These are a little bit too advanced for us at this stage. Okay, but for now, if we go to our dogs class, which we did last week. So week 8, I think we did it in week 7 as well. We had a sort command here. There was sort. We could copy this and adapt this to now. So we can do that pretty quickly. Let's do that. So we'll do it in our ArrayList class, and we'll do a sort. And we're doing ArrayList, so it's words ArrayList. ArrayList, 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 ArrayList. And instead of get dog name, it's now just get name. Okay. So we can see we've copied our dog's sorter code that we had and just changed the ArrayList name and whatever field we're sorting on, and we've got it working already. Okay. Now, one thing I did talk about in the past is if you find yourself in a beautiful house, if you find yourself copying code and changing the ArrayList name, method names, or whatever, data types, stop. And there's better ways to do it, but I can't show you what those better ways are until the follow-on course as well. So there's a thing called generic methods, which is a way of thinking about methods to make work for any type of data. That's something we cover in the follow-on course as well. Okay, so for now we've done something bad. We've copied this code, and all we did was change the ArrayList and the method that was getting used. And there's a better way to do it, and that's a thing called generic methods. But we don't do that to the follow-on course either. It's another one of these iceberg topics. Okay, but we've got it done for now. But just I'll leave that little note in there saying there's better ways to do it. And what we've done below is pretty bad, but that's all we can do for now. Okay, so we now got a sort method. Let's do the sort. So words.sort, and then we'll display the words again. Okay, so we'll get them sorted out on the screen as well. Control-1. What was it? It wasn't get name and it was get word, was it? Get word. Okay, not get name. Get word. Get word. Oh, and it's not a dog here; it's a word. Get word, and it's a word data type, not a dog data type that we're sorting by equal.
Got dogs ArrayList on the next line as well.
Oh, it is too. Yep. Cool, cool. Thanks, Wayne. All done. So here's the words in their original order. And here's the words sorted. Okay. And you might see this sorted by case as well. So if we want to make them case insensitive, we can just make that compared to ignore case. And they'll be case insensitive. Control 1, Control 2. And you'll see here now the words are sorted and it's case insensitive. Uppercase Q goes in amongst the P and the R. Okay. And let's just check we've still got the right values. In still 5, so we've moved the whole row around. If we'd done sorting by parallel arrays, it would have been a nightmare. Because when you swap words, you've got to swap counts as well. And if you've got other things as well to keep track of, like syllables, and then you've got to swap multiple arrays, it's terrible. Much better to do a data class and then an array of the data class. Okay, and any questions on that code? So we're winding up now. We've got 7 minutes to go. Any questions? Do you want me to go through anything again? We wrote some fairly complex code, but I still think this was the most complex, the one in our char counter when we were working out what the index should be, and then deriving the char back from the index later. That was a little bit of tricky code there we had to come up with. This code was more straightforward than that, but it was quite a lot of work to change a char counter to a word counter. It wasn't just a matter of changing the data type in the array. We could have made it so our code was more similar to this, the char counter code, if we'd used parallel arrays. But again, I didn't want to do that. That's a nasty solution. Because if you ever have to sort the data, you've got to sort the words by the same thing and the counts by the same thing and the syllables and whatever else you're tracking. So maybe it's a to-do, maybe do it the adapt char count.java to work for words. Need to arrays for words and counts. Have a go at that if you like and see if you like it, but I think you'll find that this way of using a word data class and then a words ArrayList data class, which is where all your processing goes. And then your interface is just got simply calling your words class methods. Okay, so one thing if you get a chance to do a bit of reading on it, model MCV. Model I've just gone blank. My mind's gone blank. Anyway, it's a way of developing applications where you have a model, which is your data classes, your brains, which is your things like the double processing, which in this case is our words class, and then our interface or views, which in this case is just our main class, our main method. That's a good way to split up your applications as well. Have your model data classes as separate classes. Have your brains in other classes above those, and then have your views and whatever in class above those. So that by working it this way, if ever your data changes or if ever your user interface changes, all you need to change is that. The other two should stay the same. If you're changing where your data lives, so it's getting it out of a database or out of a file or whatever, this should be all you need to change. Or maybe that, depending on where you do your load data from. Okay, but your interface shouldn't know where your data comes from. And these two classes shouldn't know what interface you have. Okay. So it's a good way of thinking about applications to do it that way. But anyway, this is outside the scope as well. it's just something to think about. Try and organize your application so they're in this sort of way, and that gives you really good reusability. So, are there any questions on the word counter before we go, or the char counter? Any questions? Do you want to go through anything again?
No, I'm all good.
Okay, so I'll put all that code up on the GitHub as usual. So keep an eye on the GitHub. And thanks for joining in. Special thanks to Byron and Wayne and Andrew. Special thanks to you guys for joining in. So assignment 2 is due at the end of next week, and I'll probably be lenient as well next week, like I was for the last assignment. As long as you hand it in over the weekend, sometime I won't take any penalties off. Okay, so, and if you've got any problems with anything, send me an email and I'll try and help. And I might even do individual videos. If it's something that's easy to explain a video, I'll do a little personal video for you, which is better. Okay, thanks for coming along. Do lots of practice, get lots of practice with coding, and I'll see you next week. Thank you.
Thank you.
Thanks, Wayne.